we will be talking about 1, displacement, 2, velocity, and 3, acceleration in this video. So I'm gonna cover the trig not the trig. Oh my god, I just combined the words. The big three, not trig. The big three descriptions of movement in this video for physics or for I don't know whatever you're doing. Or maybe Calc 1 where we're covering motion. But on a side note, I don't know if, yeah, you guys probably don't care, but I just hit champ on Rainbow Six Siege, so if you play Rainbow Six Siege, you know exactly what I'm talking about. But so let's start with displacement. So, wrong color. Displacement. Let's start with displacement. So what is displacement? Well, displacement is just the change in position. So let's say you are point A to point B somewhere. Your displacement is just this distance right here. Not distance, that's not the right word, sorry. This change in position. So it's the length of your change of position, just the green line. But here's the thing about displacement. Displacement versus distance. Displacement is something called a state function. And maybe that's not too important for your class. I think you would worry more about this in chemistry rather than physics. But a state function is only something that cares about the original state and the final state. It's in the wording. And distance is something called a path function. So here's a difference between displacement and distance. Displacement is just this green line here, just from point A to point B, shortest length that you traveled. But distance takes into account the path. So you could go all the way around, you can go running around, and then when you go back to B, you measure the length of this entire blue path. Hence the name path function. And the distance you traveled is the length of this blue path. No matter where you go or what path you take for displacement, it only cares about the initial state and the final state. And the initial state is point A, and the final state is point B for displacement. So it's just the path you traveled. But distance depends on the path, hence the name path function. And in chemistry, there's many things that are path functions or state functions. But this is mainly a physics video, but I'll just give you an example. A state function in chemistry would be change in enthalpy, and a path function would be something like work. So let's keep going. We're going to talk about velocity now. So velocity, what is velocity? Well, velocity, everyone knows the units for velocity are meters per second. And velocity is something called it's a vector. So direction matters. It's going to have negative or positive signs. But what is velocity? Well, velocity is just another way of describing speed. It's not the same thing as speed, but it's another way of describing speed. So let's say if you're going in this direction 5 meters per second, well, after 10 seconds you would have traveled 50 meters. Make sense? So you travel 5 meters per second. Every second you go 5 meters forward somewhere. And after 10 seconds, right, 10 seconds times 5 is 50. So you traveled 50 meters with velocity. So velocity is just another way to describe speed. And velocity, keep in mind, is a vector. And speed is the magnitude of your velocity. Those are the two different things. So velocity will have some, if you learn vectors, velocity will have some velocity will have some components of direction, like -5 I hat. Maybe if you take vector calculus, this is traumatizing you a little bit. This is I hat. Nope. It would be -5 I hat plus like 6 j hat or something. Velocity has direction, and it's going to be described with a vector. But overall, you could just think of it as speed in really simplistic terms. So how about acceleration? Well, I know acceleration might be one of the harder things to learn about. But the unit for acceleration is meters per second squared. So what does that mean? Well, it means you maybe have heard of this before, but it means meters per second per second. So just like how velocity after 5 meters, velocity is 5 meters per second after 10 seconds, it goes 50 meters. Acceleration describes the change in velocity. That looks like a C kind of. Let me fix this. Acceleration describes the change in velocity. So velocity describes change in distance, but acceleration describes change in velocity. So let's say this. Let's say you have an acceleration of 2 meters per second squared. So meters per second. And you have an initial velocity of, let's say, let's do 6 meters per second. After 10 seconds, what is your velocity? Take a guess. Take a gander. If you know how to use unit conversion, this will be pretty easy. But acceleration. So what is acceleration? Acceleration describes your change in velocity, right? So you are getting faster if you have a positive acceleration. So right now this is a positive acceleration. You're going faster. And this right here, after 10 seconds, well, your velocity, let's use the right terminology there, will be 26 meters per second. Why is that? Well, so you have 2 meters per second for 10 seconds, okay? Every single second, so every second, your velocity goes up 2 meters per second. So this is what this describes. Every second, your velocity goes up 2 meters per second. So if your velocity goes up 2 meters per second every second, how many seconds were there? Well, there was 10 seconds, so we have 10 seconds here. 10 seconds. So every single second, multiplied by 2 meters per second, and you get 20 meters per second increased, right? 20 meters per second increased. So every second, your velocity goes up 2 meters per second. Take that in, pause the video, try to understand what I said there. And then after 10 seconds, if every second 2 meters per second goes up in the velocity, that means your change in velocity is 20 meters per second after 10 seconds. That's why I added 20 plus onto my original 6 meters per second. So let's do just another exercise with acceleration. Velocity is pretty self-explanatory, but acceleration is a little harder. So let's say we have an acceleration of 3 meters per second squared, and my original velocity was my v null was, null usually stands for initial. You can also use vi for initial. So v null is equal to, let's say, 25 meters per second. So after 5 seconds, what's your final velocity? So v of f. So let's explain this. Well, every second, your velocity, your velocity goes down 3 meters per second. Why? Well, because we have a negative symbol here. So your velocity goes down 3 meters per second. Every second. How many seconds has passed? Well, 5 seconds has passed. So if we multiply 5 seconds by 3 meters per second squared, that's the acceleration, negative actually, we get negative 15 meters per second squared, meters per second, sorry. And if you know a little bit about unit conversion, these seconds cancel. So let's say you have seconds times meters per second squared. Just treat these as variables for unit conversion. This is a quick little recap on that. If you just treat s as a variable and m as a variable, well, if you multiply s by some fraction, this square cancels. So you get the unit. So you get the unit meters per second. So if you multiply 5 by negative 3, you get negative 15. So your change in velocity is delta v is negative equal to negative 15 meters per second. So all you have to do is subtract 15 from my initial velocity, and you get your current velocity. After 5 seconds of constant acceleration, you have 10 meters per second as your final velocity. So if you have any questions, put it down in the comment section. I hope this video helped.